This video is one in a series of the different types of reactions that we find when we look at the patterns that chemical reactions take. Double replacement is one of those patterns. In order to understand this topic, you'll want to be familiar with ionic compounds and how to write out and balance a chemical reaction. Double replacement reactions take, like I said, a pretty predictable pattern. In this case, we always have two ionic compounds, and as you know, ionic compounds are always composed of a metal, I just abbreviated with an M, and a nonmetal. And so basically what happens is they just swap partners. So the metals here swap places. And so I end up with my red metal paired with my black nonmetal, and my black metal paired with my red nonmetal. And sometimes the other way that this is written is we have A, B, some compound, plus C, D, and if you think about it, we're just swapping A and C. So now C will be paired up with B, and A will be paired up with D. Let's look at an example. Barium chloride reacts with sodium sulfate in a double replacement reaction. So I need to know that barium chloride is BaCl2 and that sodium sulfate is Na2SO4. And then my job here is to figure out what the products are. Barium, I'm going to think about these just in terms of their raw materials so that I don't get confused about how many of each I'm going to need in the products. Barium has a +2 charge. Sodium is the other metal. It has a +1 charge. My nonmetals are chlorine with a -1 and the sulfate polyatomic ion. I want to swap the barium with the sodium, which means that now barium will be paired up with sulfate. So I have barium, which has a +2 charge, and sulfate, which has a -2 charge. I only need one of each. So my formula of barium sulfate is BaSO4. My other product will be the sodium paired up with the chlorine. Sodium has a +1 charge, chlorine has a -1 charge, so my formula there will just be NaCl. Notice, even though I started with 2 chlorines and 2 sodiums, I only needed 1 Na and 1 Cl to make sodium chloride. Where I'm going to account for the fact that I have different numbers of sodiums and chlorines in the reactants and the products is in my next step when I balance it. And that's easily taken care of by putting a coefficient of a 2 in front of the sodium chloride. Let's do another one. Potassium phosphate, which is K3PO4, reacts with lead 2 nitrate. That Roman numeral tells us the charge on the lead. Since nitrate is a -1, I'll need 2 nitrates to balance out the +2 from the lead. And I know we're going to be swapping partners here, so I'm going to rewrite my ions. I have a potassium ion and I have a lead +2 ion. That lead will stay +2. Sometimes students want to know, since it's a transition metal, if something exciting happens in the products, the lead pretty much just stays +2. My nonmetals here are the phosphate ion and the nitrate ion. So I'm going to pair my lead up and swap it with the potassium and pair it up with the phosphate, and the potassium will be paired with the nitrate. So if I have a lead with a +2 charge paired with a phosphate with a -3 charge, then I need 3 leads and 2 phosphates to make the compound neutral. On the other side, I'll be pairing up potassium with a +1 charge and nitrate with a -1 charge, and so I just need one of each. Now I can go back and balance my chemical reaction, and I see that I will need 2 of these, so my phosphates balance, and 3 of those, so my leads balance, and that will mean that I need 6 potassium nitrates for the whole reaction to be balanced.